All right, in example 3, we're going to graph a sine function. Okay, so these are the information that you kind of need to know in order to graph sine. So normally, sine, if you were to graph it, it would be plug in an angle. So it's normally y equals sine of x, right? But then it changes because sometimes we have an amplitude that's being multiplied by the sine, so it stretches vertically, right? And then sometimes we multiply our angle before we take the sine function, and that's going to stretch it horizontally or shrink it horizontally. Okay, so when we look at this, what we want to do is we want to find out, well, what are the normal x's that we have? What are the normal angles that we come across, right? So normally we do 0. Normally we do pi halves and or 90 degrees, and pi, which is 180, and then we do 3 halves pi. We're just counting by 90s, right? And this is 270, and then we have back to 2 pi, right, which is 360. Okay, so those are the normal ones that we hit, and it just goes like this, right? Back through here, and it ends right there, right? So that's what it normally looks like. So normally we have these x's right here, but what affects that is this b, right? Because sometimes we can get to these numbers, these values of 0, 1, 0, -1, back to 0 faster, like we saw in the last example. Or if I multiply by, say, 1/2, that's going to get it slower, so it's going to stretch it out, right? So we first want to find the period. How long does it take to start repeating itself? Okay, so, and this continues to go on, right? We continue to go on like this and continue to go on this way. So it does go on forever, but we're just talking about one period length. Okay, so normally it's 2 pi, right? So in order to find the period, we have to take this and we have to divide it by b, right? So whatever's being multiplied here, we get 4. So I'm going to take my period, 2 pi, and I'm going to divide it by 4. So really, this problem is different from this one because we're multiplying everything by 4. So our period is going to get there faster, right? It's going to be faster to start repeating itself. So this is, I get 1/2, right? Or I can switch this to degrees, divide that by 4, right? So we get 90, right, for pi halves. Okay, so it's going to start repeating itself already right here at 90. Okay, so it's already going to make its way. It's going to be like this. So basically, bam, and it's going to start repeating itself already. Okay, so we know that, and then now we want to know either of these two for our period. Now we want to know, okay, how long do we normally put in numbers? Because I don't want to put a lot of numbers in here, right? I could put in infinitely many numbers in here to get these points. But notice we only do these ones. 0, pi halves, pi, 3 halves pi, and 2 pi, or their degrees 90, 0, 90, 180, 270, or 360, right? So we only have 1, 2, 3, 4, 5 x's that we use. So to find your x's, we normally have 5 x's, okay? And so even though I graph this new one, I'm still going to have 5 x's. They're just going to get there sooner, right? So there's still going to be 5 x's in here. 1, 2, 3, 4, 5. Okay, so there's still going to be 5 x's. So we want to find out what's that length in between our x's. Because notice on these it's the same, right? It's just a difference of 90 every time, right? A difference of 90. Well, that 90 just comes from 2 pi divided by 4, and that's how we get 90. Or, I guess 360 divided by 4. Or 2 pi divided by 4 is pi halves, right? Those are the same thing. So normally this distance is 90. But since our period length is different, since our period length is only 90, I'm going to divide that by 4. So if I do divide this by 4, I get what's called my interval length. What's the distance between each of my x's? Okay, and so that is my period divided by 4, because I have 1, 2, 3, 4 lengths difference, okay, between these two, right? 1, 2, 3, 4 before I start repeating myself, right? Okay, so that's why I'm dividing this by 4 to find out what this distance is between each x's. Well, my period is 2 pi, let me switch colors here, is 2 pi divided by b, right? So if I divide that by 4, wouldn't that be same as timesing by 1/4? So then these 2 and 4 can cancel out. So my interval length, period divided by 4, is really the same thing as pi over 2b. Okay, so if I take my b as 4 from the beginning of this problem, this 4 right here, and I plug it in here, I get pi over 2 times 4, which is pi eighths. So my interval length between each x is pi eighths. Okay? Or what you can do is just take your period length, whatever it is, and divide it by 4 or times it by 1/4. So here we would divide this by 4 if we're in degrees, right? So that would be 22.5. 22.5. So you could do it that way too. So it's your period divided by 4, or it's 2 pi over b times 1/4, which is the same as pi over 2b. So that's your interval length, or your interval length in degrees would be 180 over 2 times b, which is just 90 over b. Okay, so it's either pi over 2b or 90 over b is your interval length. Okay, so now I know how long I go for, and I know the distance in between my x's. Then we need to start. Where do we normally start sine? Our first x is always at 0. Okay, so our first x is always at 0 for sine and cosine. We always start at 0, and now I'm just going to add this interval length. So we get our start, and then we're going to add our interval length, which ours is pi eighths, or 22.5 if we're in degrees. So I start at 0, and I'm going to add 22.5. That's 1. And then I'm going to take another interval of 22.5, so that gets me 45. And then I want to add another 22.5, and I get 67.5. And then I want to add another one, and I get 90, right? That's my 4 interval lengths. 22.5, another 22.5, another 22.5, another 22.5. Notice that I still have my 5 x's. 1, 2, 3, 4, 5, right? So I still have those. All right, so now I can go ahead and graph my y values. So the y values I have normally for sine and cosine, I usually just have 5, right? I have for sine 0, 1, 0, -1, and then back to 0, right? So then all I have to do is look at what I'm multiplying my y values, right? This sine of x always gives you your y values. So sine of 4x is just going to give your y values, and then you multiply it by your amplitude, what's in front. So I'm just going to take these y values and multiply them by my a. Every single one of them, I'm going to multiply by a. So my a is 0.5. What's 0 times 0.5? 0. What's 1 times 0.5? 0.5. What is 0 times 0.5 is 0. -1 times 0.5 is -0.5. And 0 times 0.5 is 0. So now these are my 5 y's that go with these 5 x's. 0 with 0, 0.5. So here's 1. So 0.5 would be right here. Then back to 0. Then down here's -1. So -0.5 right there. And then back to 0. So then here's my function if I graph it. It's like a wave pattern. There's my function graphed. Okay, so how you have to do this is you find your period, which is 360 divided by your b, and then you're going to take that period and find your interval length. And your interval length is your period that you just found divided by 4. And then you're going to find your x's. Find your x's. You normally start at 0, and then you're going to add your interval length. And you're going to keep on doing that until you get your 5 x's. So your first x is going to be 0, and then you're going to add your interval length until you have 5 x's. Okay? And you can mark them down just like that. And then you're going to take your y values. For sine, your y values are 0, 1, 0, -1, and 0. For cosine, it goes 1, 0, -1, 0, 1. It's just kind of shifted over. So there's how you graph. Okay, and then you can just kind of do your curve wave pattern through there. after you dot those points. Okay, so it takes some time and some practice, but you can do it.